Hello, today we will be solving 2000 Aime Ii problem 14. We have factorial base expansions, which is pretty interesting. Usually they'll be of the form bn and then bn minus 1, and then you have the coefficient, and it's just a sum, alright? Anywho, so we have this number, which consists of factorials that have multiples of 64, not 64, 16. And then we have to find the value of this alternating sum. Here, I'll clear everything. So we can actually just rewrite this by grouping 48 factorial and negative 32 factorial, and then 80 factorial minus 64 factorial, all the way to 2000 factorial minus 1984 factorial. Now, the reason we're doing this is in this way we can see how each of these can contribute to this alternating sum. And it turns out it's not that bad. So first, let's consider expressing 48 factorial minus 32 factorial. So we can't have any 48 factorials because that's too large. So we resort to 47 factorials. The maximum we can have is 47. And if we subtract that, we get 47 factorial minus 32 factorial. And then we have to use 46 factorials now. Now note that F47 was 47 in this case. And then F46 is 46. If this was 47, that would just be too big. And then 46 factorial minus 32 factorial is left. And then this continues all the way down to when you have 33 factorial minus 32 factorial. In this case, F32 is just 32, and you get a result of 0, which is nice. So in this case, F1 through F31 is 0, and then F30 from that point on, it's just the index is the same as the number, as the value. So it's just of the form the sum from 32 to 47 of I times I factorial. Now if we actually evaluate that part, and then that continues, you just get this, right? And this sum turns out to be 8. So in essence, the alternating sum of 48 factorial minus 32 factorial is 8. And it turns out that all the other groups also sum to 8. Because it's just a similar thing, a similar process, except using larger numbers, right? Note the spacing between these numbers is always 16, right? And the thing is, you don't have any double contributions for the same factorial, right? So for example, F47 is 47 here, and then and then there's no other contribution of 47 factorial anywhere else, because these are way greater than 47. They're from 64 to 79. And so you won't get any overlap, and each group will have a sum of 8, which is nice. So now it's just how many groups there are. It turns out there's 124 numbers. In between 32 and 2000 with spacing 16. So 62 groups, each having an alternating sum of 8. And then regarding the 16 factorial, because it's negative F16 in the alternating sum, this gives a negative 1 in place of it. And so that we have to append a negative 1. So subtract 1 from 8 times 62 gives 495. And this is the solution. Thank you for listening.